So in this session, we'll discuss the Born-Haber cycle, which we can use to work out the lattice energy. So there are certain points of the cycle which you have to understand, the labels of the cycle. So a Born-Haber cycle for lattice energy. So what are the labels for the Born-Haber cycle for lattice energy? First you will have element, then you will have atoms, then you will have the ions, and at the bottom you will have compound. So what is this cycle here refers to? Look, the possibility, the Born-Haber cycle state what is the possibility that element can first form atom, then atoms forms the ions, then ions form the compound. Is same as element directly form the compound. So this is a Born-Haber cycle which state that there are two ways the compound can form. Number one, first what happened, there are elements, first elements turn into atoms, then atoms turn into ions, and ions form that ionic compound. That's one way. What is the second way? It's straight directly, if we have element directly they form a compound, so we call that as the Born-Haber cycle. And what are the labels here? If elements are forming atoms, what we call this? When elements are forming atoms, elements are forming atoms, what we call? The formation of atoms from the element. As we discussed the labels, so when elements are forming the atoms, we call that as atomization. Like we atomize or we make atoms, so we call that as atomization. When atoms form the ions, so they can form two types of ions. They can form positive ion and negative ion. So if they are forming a positive ion, the formation of a positive ion means the removal of electron. So when we remove electron, what we call? We call that as electronegativity or ionization energy. So this is ionization energy plus, because when negative ion is formed, the electron is added, so we call that as electron affinity. So when atoms are forming the ions, if it is forming a positive ion, it will be ionization. It is forming a negative ion, we call that as electron affinity. Or ions directly form the compound. If ions directly form the compound, so when ions are forming a compound, what we call that energy? We call that as lattice energy. And if element directly form the compound, when elements are forming a compound, so we call that as formation. So this is known as a Born-Haber cycle. So in a Born-Haber cycle, you have element, you have atoms, you have ions, you have compound. So basically, what it says overall energy change is same. Like what we do if we add atomization with ionization, affinity, and lattice energy. That's the cycle that root one. Like if we follow root one and add all these energies, it will be same as element directly form the compound. So practically, how we can apply this? If I say complete a Born-Haber cycle for sodium chloride. So you have to learn first the order. First we have element, then we have atoms, then we have ions, the positive and negative ions, and here we will have compound. At this point we'll have atom, here we will have ions, both positive and negative, and at the last we will have this compound. Now, because we want to write for sodium chloride, which is NaCl. So what compound we need? We need sodium chloride, so we need NaCl in a solid state. What are the elements reacting here? Because to form sodium chloride, the element which react, the sodium element is there, sodium atom will be there in a solid state, and chlorine, which is a gas. But because the equation must be balanced, so here we only need one chlorine, but in a chlorine molecule we have two chlorine atoms. So if we have half chlorine molecule, so in A levels you can use these fractions to balance the equation. It is acceptable. So if we have half chlorine molecule and one chlorine atom, it will give one molecule of sodium chloride. Then we need atoms. So what are the atoms? So we need sodium. Sodium is in solid, so we need sodium atom in a gaseous state. We also need chloride atom in a gaseous state. And here are the ions. So we have sodium ion in a gaseous state, and we will have chloride ion in a gaseous state. Is it clear till now? The cycle? Anyone having a doubt till this point? Now what happened when we complete this cycle? So first element form the atom. So if elements are forming the atom, so what is this energy? This is called atomization. So this is atomization of what? It is atomization of Na and Cl. Because sodium is atomized and chlorine is atomized, so this energy is atomization of sodium and chlorine. Then sodium atom turn into sodium ion and chlorine atom turn into chloride ion. So this is because sodium is losing electron, so it is ionization of sodium, or first ionization, because one electron is removed from sodium, and it is first affinity of, or electron affinity of, chlorine. So chlorine having a first electron affinity, because chlorine we added, one electron is added, and for sodium the electron is removed. And then when sodium ion and chloride ion turn into sodium chloride, what we call that? We call that as lattice energy. Or elements, these elements directly form the compound, so we call that as formation. Is it clear? This Born-Haber cycle for sodium chloride. So this is a complete Born-Haber cycle for sodium chloride. If they say we have to complete Born-Haber cycle for magnesium chloride, so Born-Haber cycle for magnesium chloride, element, atoms, ions, compound. So what we need here, we need MgCl2. So that is the compound which we need, MgCl2. So we should have element magnesium, which is in a metal is a solid, and we need chlorine Cl2 in a gaseous. Then atoms, magnesium solid turn into magnesium atom in a gaseous state, and because chlorine molecule is there, so it will produce two chlorine atoms, because one molecule, half molecule produce one atom, so full molecule will produce two atoms. And here we should have ions. So what are the ions? So magnesium ion and the chloride ion. And how many chloride ions should be there? Two chloride ions. So what happened? The possibility, this turn into atom, the atom turn into ions, the ions form the compound, is same as element directly form the compound. So what is this energy? This is atomization of magnesium plus, because we are producing two atoms of chlorine, so it is twice the atomization of chlorine. Why twice atomization of chlorine? Because we are producing two atoms of chlorine, that's why it will be two times the atomization of chlorine. Then we are producing magnesium plus 2 ion and chloride, 2 ions of chloride minus 1. So it is, this one will be the sum of first ionization, because electron is removed, first ionization of magnesium plus second ionization of magnesium, because we are removing 2 electrons from magnesium, plus 2 times the first electron affinity. Chlorine, because we are producing two chloride ions. As you can see, we are producing two chloride ion with a charge -1. So when one chloride ion is produced, it's called first electron affinity. Like chloride ion with a charge -1, it's called first electron affinity, and we are producing two. So that's why it is multiplied by 2. And when ions form a compound, we call that as a lattice energy. So this is a lattice energy. And when element form the compound, so we call that as formation of that compound. So this is the Born-Haber cycle for magnesium chloride. Is it clear, this example? Anyone having a doubt or a question related to this magnesium chloride? So in the next session, we will do more examples related to the lattice energy. So for what I want, that I want everyone to memorize these definitions: the enthalpy change of formation, the enthalpy of atomization, first and second ionization, first and second electron affinity, enthalpy of lattice energy. So this was topic 1, which is about topic 3, which was about bonding. So I'll end the session and share this recording with you.